Bismillahir Rahmanir Rahim. In the previous two or three discussions, we have completed chapter 12 of your book, and also we studied few things regarding correlation coefficient, that is a part of chapter 13 of your book. So today I want to give an overview of few things, and then we will move to the idea of regression analysis. So a brief overview of the analysis of variance that we covered in few lectures was that initially we started the analysis of variance where we considered variances from two populations, and then we set the null and alternate hypothesis in this way. You can see in this slide, if you see, this is chapter 12 of your book. We used F statistic, and initially we set the null and alternate hypothesis in this form, where we wrote sigma square 1 and sigma square 2. So these were the variances from first population, and this was the variance for the second population, and we took help of F statistic to prove or disprove the null hypothesis. Then this was the test statistic basically, and we also used this test statistic later on, where we considered population means when there were more than two populations, and we considered the equality or inequality of the population means there in that case. Then we used F statistic again, and for that we set the null hypothesis. As you can see over here, the means are equal in the null hypothesis, and in the alternate hypothesis we said that at least one pair is not equal. So the first case that we discussed was the case where we took equal values in each sample. So 1, 2, 3, 4, 5. There were basically three industries, and we took sample contained 5 values in each from each industry. Okay, so in this case we set the null hypothesis as this, you can see, and finally we proved or disproved the null hypothesis, definitely by using the specific technique that we used over here. So we took help of such table, where we calculated the values that we used in the formula to find out the calculated value of F. So in detail you can find out these calculations and how I found F calculated over here. So finally I set the ANOVA table. I wrote the ANOVA table, where I found the values for the between treatments variation and the within treatments variation. I found this BESS or ESS, or we also call this regression sum of square, that we use later on. And then there is total variation in the treatments. So this was the case where we took into our account only one-way analysis of variance. We took only treatments in our account, and there was no description or explanation regarding the blocking variables, blocks. So the next topic that we covered was from the same one-way ANOVA, and where we considered the treatments where unequal sample values were there. So you can see, yes, this was the case where we took sample values, but they were unequal. So in the first, let's say, treatment, 1, 2, 3, 4 values were there. Then in the second, there were 5 values. So values may change in different industries or different treatments. So basically, we call these as treatments. Okay, this was the second case, and then we proved that in case we are going to reject the null hypothesis and we are going to accept the alternate hypothesis, that will definitely mean that some pairs of means are not equal. So let's say mu1 is not equal to mu2. We have to check this. Then we use this formula. You can see this formula. This is the formula for confidence interval. And we utilized values that we found from x1 for x1 and x2. So this was these were the values that we obtained from the given data, using utilizing the given data, these data values. So we added and divide by 5 to find out x1 bar and x2 bar, like this. So this whole discussion is there in the videos that have already been recorded. So this is just an overview. So finally we obtained the value for f statistic, and this value we finally compared with the critical value that we obtained in the decision rule, utilizing the numerator's degree of freedom and the denominator's degree of freedom, and then what was the level of significance, and then we used f statistic table to find out that critical value, like you can see over here. This was the critical value. So we compared finally the calculated value with this value to have the answer. Okay, then we discussed two-way analysis of variance, and if you see that two-way analysis of variance, we introduced blocks in that case. So we also took help of Excel to find out these values. So how I found these values using Excel, you can see this in the previously recorded lectures. Then we considered two-way analysis of variance, and simply we introduced blocking variables there. So these were the treatments, and we introduced blocking variables there. I mean, by introducing this blocking variable, I mean another impact and another effect of something we wanna consider at the same time. Let's say in this case, the type of the shampoo was dry, and this was the $7 million was the sale for dry shampoo. And we see that in June, $7 million sales were there. So at the same time, this 7 is for dry type of shampoo, and at the same time for the month of June. So similarly for others. So we consider that is there any difference in the sales because of these types of the shampoos or these months. So sales are, you can say the change in the sales or the average sales are different because of the variation in the months or in the types of the shampoo. So we considered this situation in detail in the previous lecture. And in this case, we set the null hypothesis as you can see over here. We basically set two null and two alternate hypotheses in this way. So in this way, you can see H naught bar was the mu1, mu.1, mu.2, mu.3. So in this case, we considered treatments, and in this case, we considered blocks. And in this case, the blocks are months. Okay, so similarly, we utilized this particular technique, and we found the values that were required to utilize in the utilize in finding the calculated value of f. So between blocks variation, this is the between blocks variation, this is between treatments variation, this is the total variation, and this is the within treatment variation, or at the same time you can say within blocks variation. Though the same value will be there in both cases. So ESS, or we also call this error sum of square. So we utilize these all values that we found in the ANOVA table. We wrote these values, and finally we find out we found F1 and F2, and then we simultaneously compared these values with the critical values that we obtained in step 4. So then we decided that whether we are going to reject or accept the null hypothesis, and then we also found the same values utilizing Excel. So Excel may help us in finding out these values, but as we are interested in manual things, because normally when we are on campus, we have to write down these things manually, and we don't use Excel in that situation. So therefore, we also, although we have learned that how we use Excel, but you have to manually solve these things on your answer booklets. So I'm not interested in having this output on your answer sheet. I'm interested in having this such tables on the answer booklets. So definitely the exams will be online, and you would definitely be required to find out the values utilizing this strategy. So all values you find out manually, and then you will finally decide that whether you are going to reject or accept the null hypothesis. So this is all for you can also see after rejection of null hypothesis, we also find out the you can say the pairs. The we have to confirm that which two pairs are not equal basically, and for that again you will use that confidence intervals formula that I have just shown you, where I have used x1 bar minus x2 bar plus minus t into msc into 1 over n1 plus 1 over n2. So that formula. So you are familiar with all these things. I have given a simple overview of all these things. And then we move to chapter 13 of your book. And I also explained the correlation coefficients concept in detail. You can see the previous video for that. But a simple overview, if you want to see, it is there. What is correlation coefficient? Basically, there are two variables in which we are interested to find out the relationship, that how one variable is related to the other variable. So basically, if we see the simple regression analysis, or you can say the, if we want to see the association between any two variables, so one variable definitely will be depending upon the other variable. And remember that there should be some common sense, and theoretically there should be that should be based, the relationship should be theoretically based. So one variable will be independent variable, and the other variable will be the dependent variable. So dependent variable is basically depending upon the independent variable. So you can see over here, if I wrote somewhere over here, the equation that is basically, let me write down here. So let's say y is equal to uh, uh, let's say this is the equation, and basically we call this equation population regression function, or we also call this population regression line, because we obtain population regression line from this. So we will see this equation later on. Simply, if you are interested in finding out some relationship between x and y, some relationship between x and y, so you can see if we will give some value to x, we will definitely obtain some value for y. Okay, so which type of relationship is this? There is a positive relationship or negative relationship, that depends upon this beta. The value of beta will determine that the negative relationship is there or the positive relationship is there. So using equations we can also find out, but if you see the graph, so normally we take the independent variable on the horizontal axis and the dependent variable on the vertical axis. Okay, and then we find out x bar first. Definitely these are the sample data. There are sample data values in the series that we have named as x, the independent variable, and there are some values, sample values for the y variable. Okay, so we find out y bar, and then we see that what is x bar and what is y bar in this way, and then we see that where the values are more, in which quadrant more values are there. So if there are more values in, this is the first quadrant, this is the second quadrant, third quadrant. So this is an overview, so therefore I am simply moving quickly onward, because today's topic is regression analysis and we are not interested in this, but simply we want to link things. So therefore I have I think it better to explain it again. So you can see we will have some line like this. This is there is a positive relationship in this case, and if you put dots in the quadrants like this. So let's say there was some value of x, there was some value of y. Definitely you will give the scale from 0 onward. There will be some values, there will be some values, and you will see that for which value of x, what will be the value of y. So see, let's say there is a 5, let's say there is x value is 5, and for that the value for y is, let's say, 10. So you will put a dot over here at this point like this. So for different values of x, you will obtain different values of y. So let's say you find out more dots in fourth and the second quadrant. So the line will be like this. So this will indicate that there is a negative relationship between x and y. So graphically, you can see that what relationship is there in the two variables, and you can also find out this relationship using the correlation coefficient. And correlation coefficients formula is we normally represent that by r, and the r is equal to, you can see over here in the uh, PowerPoint slide. This is the formula for R. Summation x minus x bar, y minus y bar. So x is basically a series of all those values that are against x, and all those values, the values that are available, the sample values that are available for y series. So you will substitute one by one values in this, and then you will find out what is the value for finally for the summation when you will have the multiple of these two. So that value will become your numerator. I have calculated it in detail. If you see over here, in this case, previous class, I have found it. And for detailed discussion, you can see the previous lecture. Okay. I think in Excel I did this. So, however, you can see in detail in the previous lecture. I think this was the file. So this was single factor ANOVA. I did it for you. This was the case where I used the shampoos example. I calculated in the Excel. Okay. So I don't remember that where I have put that sheet. But you can find out the values in this way. Let me write it down easily. I feel it easy to write it down in the Word. So the formula is x minus x bar multiplied by y minus y bar divided by n to sx sy. Let me check it. Let me check it that it is correct or not.
N
N
minus
minus 1.
1.
Minus 1.
N minus 1 is there. N minus 1 is there. So you can write it down as n minus 1. N minus 1. So you can find out all these values using Excel, or you can write down a table. So there will be some values for x, 3, 4, 9 like this. And there will be some values for y series, let's say 9, 10 like this. Fine. And then you will find out x minus x bar. So simply you can add the values x, 3 plus 4 divided by 2 in this case. That will be your summation for x divided by 2. You will have x bar, and then you will find out this series x minus x bar. Then there will be a series for y minus y bar. Then you will multiply these two, I mean x minus x bar multiply by y minus y bar, and finally you will obtain some value for that will be sum for x bar, that will be x bar sorry, x minus x bar, x minus x bar multiplied by y minus y bar. So you will have a single value for this. That will be your numerator. and then you will find out Sx and Sy. So you can find out Sx and Sy using some formula. You are already familiar with that formula. In this case, it will be x minus x bar square divided by n minus 1 square root. And when you write it down for y, it will be summation y minus y bar square divided by n minus 1 square root. So simply here in this case y will be there, here in this case x will be there. So all these values you will find out utilizing the formulae that are there available. And when you will obtain these values, you will substitute those values in this formula to find out correlation coefficient. And basically we are interested in knowing that what is this correlation coefficient. Correlation coefficient is basically a measure that gives you the relationship between the two variables. So the value for correlation coefficient is from -1 up to +1. It could not be less than 1. It could not be more than 1. It will remain in between these two values. And -1 will represent that there is a perfect negative correlation. Positive value will represent positive value that is equal to 1 will represent that positive perfect positive correlation is there in between two variables. If correlation coefficients R value is equal to 0, then you will say that there is no relationship between the two variables. Similarly, strong negative correlation, strong positive correlation will be there when it is from 0.5 up to 1. So as the value is near 1, more strong relationship will be there. As the value is near -1, more strong, or you can say the stronger negative variation will be, negative correlation will be there in that case. Similarly, if the values are near to 0 from this side, weaker negative correlation will be there. If the value is near to this side from 0, positive side, you will say that weaker positive correlation is there. So let's say the value is 0.1. So 0.1 is representing that there is a weak positive relationship. And let's say there is -0.1. That will be an indication that there is a weak negative correlation there. So this measure is very important. This measure gives us the degree of relationship between the two variables. Fine. So this all you know from the previous discussion. Okay. So if you see now, there is an equation like this: y is equal to alpha plus beta x. So we call this now I have started regression analysis. Regression analysis, you can simply say that there is an equation from which we obtain the relationship between two variables x and y, or in multiple regression analysis there may be more than one independent variables in the equation, and we one by one see that what relationship is there between the two variables, independent and the dependent variables. So in that case, you may write down, this is the simple regression equation, and if you will introduce some other independent variables, let's say like this: alpha plus beta 1 x1 plus beta 2 x2 up to so on. So it's upon you that how many variables are you are going to write down or introduce in the regression equation. So this will be a population regression function. Okay. And these things you will study in detail in econometrics, but simply have an overview, and this will help you in considering things when your teacher will explain things in the course of econometrics. So simply see, this is the equation, simple equation: alpha plus beta x. So now this is the population regression function. So if we have only you can see one variable in case of population that is affecting some other variable y. So you can see that we have already seen the example where we saw the situation that sales representatives are making calls to the customers, and based upon that the printers are being sold. Okay. So in that case, you can see that the more calls are there, the more sales are there. So sales are depending upon the telephone calls that are being made by the sales representatives. So in that case, you can see that one variable is dependent variable and the other variable is the independent variable. So let's say this is the case where some independent variable is there, calls, let's say. So calls are independent because any sales representative may calls any number of calls. It's upon him that how many people he contacts in one day, let's say. So because of that context, how many become inclined to purchase the printer. Okay, or if it is a case of credit card, so that is the case which you are familiar. So if it is a case where credit cards are there in this situation, then more cards are there, more credit cards are there, or the case is otherwise. So you have to see that whether there is some positive relationship between these two. Okay, so for that you have to find out. The one way was that I simply draw the uh, graph, and I put the dots in the quadrants, and then I saw that there is a positive relationship or the negative relationship. But you can see over here that this is an equation, and to consider that whether the positive relationship is there or the negative relationship is there, for this we have to have the value of this beta. This is the slope parameter in case of population. So if we find out the value for beta, then the sign of this beta, the slope parameter, will help us in saying something about the slope of the or you can say the relationship between the correlation between x and y. So let's say the negative sign is there for beta. So we have some value of beta that is with negative sign. So then you will say that as we will increase the value of x, overall the result in the right hand side of the equation will decrease. So it means that increasing x will result in decrease of y. So there is a negative relationship. So if let's say the result or the value, the answer for beta is a positive value, then you will say that there is a positive relationship between these two. So there is no need of drawing a graph over here. Simply you can find out the value. If you can find out the relationship between x and y if you simply have the value for beta. So what you will do in econometrics, you will find out simply the you will prove. I am not going to prove this, but you will prove in econometrics that what is the value, what is the formula for this beta. This is the population parameter. What is the formula for this, and what is the formula for this? That will help you to find out the value, or you can say the relationship between x and y, or how much x will affect y. Okay, so you will become able to measure this, that what effect of x will be there on x. So the effect will be measurable in that case. But the issue is this, that normally we see that only one variable is not there in the picture that will affect y. There may be some other factors that may affect y. So in simple regression analysis, we simply take into account one variable, only x variable, one independent variable, and we say that other variables are also there, but we don't have data for them, or we are unable to see the effect of those you can say those variables that we don't know, the data for which are not available. So we are unable to take into account those variables. So therefore what we do, we take into our account another term that we call a stochastic term, mu I. We represent it with mu I. So mu I basically captures the effect of all those variables that are not there in the equation. So let's say in this case, where sales representatives are there, and they are making calls. So one reason for the more sales of the printers that they are selling is the calls, phone calls that they make. And there may be some other reasons. Okay, there may be a reason that the talking style of a sales representative is so good that people are attracted. Okay, so similarly, there may be so many other things that may result in more sales of printers. Okay, so data for them, if let's say there is a, let's say in this case a good behavior may be represented as 1, that will be called a dummy variable, and if the behavior is not good, you will write down the value, you may write down the value as 0. So similarly, you may utilize, if some qualitative variable is there, for that you can use the value as values as 0 and 1. Otherwise, there may be some other variables for which the quantitative values may be available, but let's say readily those are not available, but their impact will be there on the sales of the calls, okay? Sales of the printers. Okay, so if this is the population regression equation, okay, then you see that we can only take sample values into our account. So in this case, if you are going to take into your account, or you are randomly selecting some employees or some sales representatives, so those may be few. You may select 10 or 15 or 20, but if there in that firm there are 500 employees, so it will be a difficult task to take all those sales representative into account, and then you will take into your account all those calls, and then you see that how many printers are being sold. So taking into account the whole population is not always an easy task. So for that reason, we take into account sample data values, and we normally say that whatever is true for by whatever values we'll have using the sample data, that and the results that we will find, that will be true in case of population. So if this is the population regression equation, uh, then we can't straightforwardly find out the value for alpha and beta. Okay, basically we are interested in finding the values for alpha and beta, but we cannot straightforwardly find it out because we are not taking into account the whole population. This is the population regression equation, or from this we can find out the you can say the population regression line utilizing this. Okay, so well, you can say that this is the population regression function. Basically, this is the population regression function from which we can find out the population regression line. So if this is the population regression function, you can also call it PRL. Okay. But as we are unable to find out the values for these parameters, so what we do, we take into account sample. Okay, and remember that if you are interested in using sample data, then you may write it down as, in your book it is instead of alpha, A is written over there, but you can write it down as alpha hat plus beta hat x plus mu I hat. So now it will become sample regression function. It will become sample regression function, and there will be a hat over y. So this will mean that now you are using sample data values, and by using sample data values, whatever you will find the value for beta. So now this beta is not a population parameter. Now this is sample statistic, or you can say this is a sample estimate. Okay. So estimate for this value, this is the sample statistic, this is the population parameter. So whatever is the value for beta hat, we will say that this is the best estimate for beta. So point estimation, you know, you are familiar with this concept, that point estimate means whatever is true for the sample, that is true for the population. This is the best estimate that we can provide. Okay, and we basically only reduce the difference between these two, but we cannot remove the difference between these two. Okay, so we can only reduce the difference between these two, but we cannot remove the difference because we are using sample data, and sample data will give us beta hat, not beta. So that will be a best estimate for this, but that could not be equal to beta. Okay, so for that line, you can best think, if you see the better explanation will be if I draw a graph like the graph for you. Let's say there is a line like this, and I say that I have obtained this line. You can say this is an imaginary line, population regression function. I use the population regression function and I found this population regression line. Okay, so population regression function is this equation. And utilizing this equation, an imaginary line I obtained is like this. This is the population regression line. So you can also write it down as population regression line. Population regression line. Okay. So this is a line that we want to obtain, but we cannot obtain this line straightforwardly because we are using sample data. So let's say Mr. A is going to select a sample, let's say the sample of 10 values that is comprised of 10 values. Mr. A is selecting 10 values from 500 from the data, from the population data that is comprised of 500 values. So only 10 values random selection is there. So definitely the values that Mr. A will select will not be the same with the values, the same as the values that Mr. B will select. So let's say Mr. A is selecting these values. He obtained the values and he put those values on the graph. Okay, these are the values that Mr. A selected. Some other person obtained 10 values and he put the dots like this. So definitely the values will not match. Everybody will randomly select different values from the population data. Okay. Okay. So what will be the situation? The situation will be like this, that for everybody there will be a different regression line. Okay, so all those lines, let's say this red line is has been obtained by Mr. A. Some other person is going to obtain another line, and that is this line. Mr. B has obtained this line. So according to dots, Mr. B obtained this line. So how he will obtain this line and how he will obtain this line? So let me draw it again. This is the situation. Let's say Mr. A obtained these dots. Okay, and he is going to draw a line like this. So this is the best estimate that he can. So he's thinking that this is the line that I'm going to draw in between the dots. Okay, so I am I'm going to pass this line from the center of the dots. Mr. A's best guess is this. But there is another boy whose name is Mr. B, and he is going to see that, no, sir, my line is like this. And it is again going from the center of the dots. Okay. So let's say there are so many guys, and everybody is making his own guess. Okay. Somebody is going to say that, no, sir, this is the best line. This is passing exactly from the center of the dots. So the number of dots that are above the line is same as the number of dots below the line. So this will be the best guess. Okay, so if there are infinite, you can say, people are there, so everybody will make his own guess. So there will be several lines. There will be so many lines over here. Okay, and we are interested in having the best line. The best line. Which line will be the best line, by the way? All these lines are the sample regression lines, and this is the population regression line. So which line will be the best line? There will be a unique line. There will be a unique line that will be just similar to the population regression line. Okay. There will be a single line that will be over the population regression line. Will there be or not? Are you listening to me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So be with me, please.
Yes, sir.
Be with me. So which line will be the best line? We are interested in having the population parameters alpha and beta, and we will utilize alpha hat and beta hat, these values into our account. Okay. So using this line, we will have population regression line. So an imaginary line may be there, but there will be a single line, only one line, one and one unique line will be there. There will be a sample regression line that will be simply over this line. Okay. Otherwise, other lines will be above or below, or their direction will be, there will be a line like this, there will be a line like this. So there will be several lines, but one line will be there that will be there on PRL. So the line, let's say this is the population regression line, and the same line is sample regression line. So that sample regression line that will be above the population regression line, that will be the best line. Okay, so we are interested in having that line. Exactly, we are unable to find out the exactly that line that will be above this side, but above this line, but there will be a line. Is it or not? Out of this so line,
Yes,
one
sir.
line will be there. That will be
Yes, sir.
simply above this line. One line will be there.
Yes, sir.
Is it or not?
Yes,
Yes,
sir.
sir.
It is here.
So it means that what best can we do? We cannot have simply the same line, but what best can we do is that we simply reduce the errors that are there in the line. So the errors are like this. You can see over here. If you see, so you can see there are several lines, okay? And we are interested in the best line. See this graph. Some dots will be above the line, some dots will be below the line. So Mr. A is saying that this is the best line. Mr. B is saying that this is the best line. So you can see that there are dots, 3 dots are there. And Mr. C is saying that this is the best line. Okay. So you can see the position of the dots. The position of the dots are same, scales are same. But this is my best guess. This is Mr. A's best guess. This is Mr. C's best guess. Fine. So we utilize a method that we call ordinary least square method. Ordinary least square method. What we do in that method, we simply minimize the you can say the distance between the error term, okay, or you can say the sample regression line and the stochastic term, or the difference. The minimum is the difference, okay. The best will be the line. So you can see that this dot is above the line, and you can say if this is the value 12 and here it is 16, so the difference of these two will be 4. So similarly, the difference of two values here in this case is 2, in this case 2, but in this case you can say the value for x is you can say at this point is 18, and the value of x is 4 and the value of y is 18. Okay, but the line is passing through this point, and at this point let's say this is the value as 12. The value of y is 12 over here, and the value for x is 4 over here. So the distance between these two will be 18 minus 12. The answer is 6. So 6 is the difference. Okay. Similarly, in this case, 8 is the difference. Okay. So what ordinary least square method do? How ordinary ordinary least square method or OLS method, how it helps? You can simply see. What will you do? Take square of this value, 2 square. This is the difference. The difference is of 2. Take square of 2. And then there is 4. Take square of 4. This is 16. 2 square of 2 is 4. So add these values. The answer is 24. Similarly, take squares of these values. Okay, so I have taken. You can see over here. So 24, 44, 132. These are the answers. So this is the minimum answer. Preferred regression line because of least sum of square deviations. So these are the deviations from mean. So this line is basically passing through the means. So in this case, if you see, x bar will be there on this line and y bar will be there on this line at some particular point. Okay. So this is the line from where the deviations from the mean or the sample regression line are minimum. Okay, so therefore the word least is there in the method. Ordinary least square. So why least square? Because of this fact. because of this fact, because we take scare and we see that where there will be a least scare. Okay, so in this case you can say that the least scared value is 24, otherwise the values are more than this value. So you will obtain, you will see this value, and you on the based upon this value you will say that this is the best line, this is the line, sample regression line, that will be near to the population regression line. So this line may give us the best result. The best result regarding what? Basically we are interested in having, definitely you have some values of, there are, there is x value, x series and y series, these two series are there, there are some values given, fine. So basically you are interested in having an equation uh, where you give some value of x and you obtain some value of y. Some values are given, let's say the values of x are 3, 9, 10. So for 3 you obtain 12, for 9 you obtain 21, for 10 you obtain, let's say, 30, let's say. So now you will substitute 3 over here. Okay, so you will have some value of y hat. That value of y hat will not be like this. Okay, because this is the value that you are going to obtain. This is the predicted value of y. Okay, so this value of predicted y value will be there on this line. Y hat, the values for the y hat, all those values will be on this line. Fine. But the actual values are not those values. Let's say against 3, against the value of 3, the value of y is 12. Okay. But in fact, when you will see the predicted value, predicted value will be there utilizing the formula, this formula, x, this formula, x, this formula. Utilizing this formula, you will obtain the value. Okay. So this value will be a different value. This will be a predicted value. So 3, 9, for 3, 9, 10, there will be some values. But if there is some other value that you want to see, let's say if you are interested in having some idea regarding the, you can say GDP, let's say. So GDP of past 10 years, you have data for that. Okay. And now you are in 2021. Okay. And you have the past data. So if you have such equation in front of you, then what will be the value for the GDP in the next year? So for that, if only one variable is there in consideration, okay, so you will give the value for that. So this is the, let's say, consumption of the, if this is the consumption level of the people, what will be the value for the GDP? Or if this is the investment level, then what will be the value for y hat? What will be the predicted GDP? Fine. So what will happen in future? What will be the predicted value? What will be the forecasted value? Okay. So we are basically interested in finding out that value. So for that, we have to have these estimates. So if we have some value for beta hat and we have some value for alpha hat, then it will become easy for us that if we substitute any value of x, then we will be able to find out the predicted value. So this is the simple regression analysis. If you have, let's say there are some other variables x1, x2, x3 up to so on. So for that, if you have the values for the these parameters, these estimators, okay, then you will be able to find out the predicted value in which you are interested, that what will be the next year's value, next day's value, next month's value. Okay, so based on the past data, you will be in this equation will make you able to find out the predicted value that that is for the future. Okay, so this is very interesting if you see. So what we do, we in the econometrics find out the prove the formula for beta hat and alpha hat. So simply, if you see what is the formula for alpha, this is if I recall, y hat minus beta y hat beta hat x bar. This is the formula for, this is the formula for alpha hat. You can say this is the intercept. What is this? This is the intercept, and by intercept we normally mean that this point. So this is the point. This is the point that we call A or alpha hat. Okay. So the line or this curve starts from here at this point. So this is the point alpha. So value for alpha hat could be find out using this formula. So alpha hat is there. It means that this is the sample regression line, and this is the best estimate for the population. It means that simply alpha will be there in case of population. So that is the best estimate that we can give for the population regression function. Okay. And what will be the slope of this curve? That will give you that you will have taking into account this value beta hat. So value for beta hat will be there, and that could be find out using this formula. Beta hat is equal to, if I recall the formula, it is S y over Sx. So you know what is Sy and what is Sx. So standard deviation that you will obtain from Y series, standard deviation that you will obtain from the X series. Sample data series are there. So you will find out these two, and then this is the correlation coefficient. When you will multiply this with these two, you will obtain beta hat. But in the econometrics, your teacher will prove the formula as he will give you the value for, let's say, let me write down beta hat, the value for this that you will prove in econometrics, and the same answer will be there if you take into account this formula or the formula that you will prove later on in the next course will be like this: xi minus x bar multiplied by yi minus y bar. So you can see that this is there in the this is there, this numerator looks like the same that you wrote in the correlation coefficients formula, summation x minus x bar summation y minus y bar. So same r is there. So when you will transform the equation that you will obtain in the next course, you will finally have the form of the formula like this. In the denominator, you will see this term xi minus x bar square. Okay. So if you are going to have the value for beta hat, you can utilize this formula or take help of this formula, or you can take help of this formula. Same answer will be there. And similarly, the formula for alpha hat will be same like this. That will be same. Okay. Only this formula, the shape of the formula is different, but the result that you will obtain, that will be the same. So you will prove this formula later on in the next course. Okay. So these are the estimators. We call these values as estimators, and these estimators are basically the best estimates for the population parameters. We are calling these as estimators because these are the best estimates for the population parameters, and population parameters are alpha beta, not alpha hat beta hat, but in fact alpha and beta, for which we are unable to find out the exact values. So we say that these are the best estimates. Alpha hat is the best estimate for alpha, beta hat is the best estimate for beta. Fine. So you will prove the formulae later on, but I have simply given you the concept that what are the benefits of these two. So in the multiple regression analysis, definitely there will be more than one independent variables, and for each you will see that what are the values of the parameter of the estimators, and based on that you will see that those are the best estimates for the population parameters. Okay, so these are the population regression function. This is the population regression function and the sample regression function. Then you can solve different questions utilizing this concept. But before that, better would be if I explain the concept that in the previous case, if you recall your memory, to see the whatever is true in case of sample, whether that is true in case of population or not, we set a null and alternate hypothesis like this, where I wrote, you can see the previous lecture for this, rho is equal to 0 and rho is not equal to 0. Okay, why, where were we using this null and alternate hypothesis? We use this null and alternate hypothesis where we were talking about the correlation coefficients. So we proved that, let's say r is equal to some value, let's say zero point 0.8. Okay. So we obtain this value, and we are seeing, we're looking at this value. There is a strong positive relationship between the two variables if r is equal to this. But we want to prove that whether whatever this r we have obtained utilizing the sample data. Okay, so we want to prove that whether the strong positive relationship is there in case of population or not. So for that we have to set the null hypothesis. So in this case, when rho is equal to 0, this will mean that there is no correlation between the variables in case of population. If we take the whole population data into our account, I mean all values of x, all values of y. So if rho is equal to 0, this is the population parameter rho, representing the relationship between the two variables. It means that rho is equal to 0 means there is no correlation between the two variables. If rho is not equal to 0, it means that there is correlation between the two variables. So that if you are going to reject the null hypothesis, definitely you will accept the alternate hypothesis, and you will say that there is a correlation between the population variables. Population, you can say x and y, two variables that are the part of population. So we set the null hypothesis in this way in the for the correlation coefficient. But you can see over here in this equation there are alpha and beta. There are alpha and beta. So you have to see that there will be definitely some value for alpha hat, there will be some value for beta hat. This value may be positive, this beta hat's value may be negative, any value may be there. So you have to see that what is whatever is true in case of sample, whether that is also true in case of population or not. So for that you have to set the null and alternate hypothesis. So in this case, if you see previously in this case where you utilized the correlation coefficient, what was the test statistic? You used t. T was equal to, if you recall your memory, r into n minus 2 divided by 1 minus r square. We have done this. This was the formula that will give you the calculated value for t statistic, and from the t distribution table you will find out the critical value, and then you will compare, and then you will say something about the rejection or the exception of the null hypothesis. That was this and this. That was this rho is equal to 0. Okay, but in this case, the next case is this. We are interested in knowing that these two values, alpha and beta, alpha, and so definitely you will find out some value for beta, you will find out some value for alpha hat, and then the next step is that you have to prove that whatever is true in case of population, that is also true for population. So for that you have to set the null and alternate hypothesis. Null and alternate hypothesis. How will you set? You will write down H naught. Let's say in first case, you may write down the null hypothesis as, so whatever is true in case of sample, whether that is also true for population or not. So for that you have to set this H naught H1. H naught in that case, as your alpha is there, so you can write down alpha is equal to 0. This will mean that the if the sample regression line is starting from this point, okay, if alpha is equal to 0, in case of sample regression function, the same situation will be there if we take into account the whole population data that we can't take into account. So we are just imagining, and alpha is not equal to 0. So if you will reject this null hypothesis, it will mean that alpha is not at this point. It will be slightly above or below. So it depends upon the situation. So you also able to find out that. Okay, so that you will learn in econometrics. Okay, the other null hypothesis and alternate hypothesis will be H naught. This will be the one situation. The other situation will be for beta. So I am not putting hats on this because in the null and alternate hypothesis, I am supposed to write down the population parameters, not sample parameters. Okay, so therefore beta, not beta hat. Beta is equal to 0 and beta hat is not equal to 0. So again, you will prove this. And which formula you will use to prove this? We are interested in writing down that formula. That formula you can see from here. If you see, yes, this is the formula. So you will set the null and alternate hypothesis in this way. Okay, there may be a situation like this, greater than or less than equal to. So what we call this, testing the significance of the slope. So we are basically interested in finding out the significance of the slope. So how will you find out the significance of the slope? We are interested in finding out whether the slope, you can say beta, is equal to 0 in null hypothesis or it is not equal to 0. Okay. So this formula you will use. T is equal to B minus 0 for SB. But in this case, you can see, as we are using, instead of B, we are saying that it is beta. So beta hat minus beta divided by SB. So this will be SB hat, because we are not using B, we are saying that it is beta hat. In your book, it is B. So you can say small alphabets A and B are being used for the estimators, okay, or sample statistics. So this is basically the formula that you will use to find out the calculated value of T, beta hat minus beta. So beta hat, definitely you will find out using the formula that I have just given you, where R is equal to S y over Sx. So the value you will find out from that. And if you see this formula, some value of beta hat will be there, and you are setting the null hypothesis in which you are saying that beta is equal to 0. So therefore this is equal to 0. And S beta hat. So S beta hat is the value that you would have to find out, because beta hat you have already found, and beta is equal to 0 you have set over here. Okay. And if you have the value for S beta hat, then you will be able to find out the calculated value for T. And once you find out the calculated value for T, you will be able to compare it with the critical value that you may find out from the T distribution table. Okay. So a degree of freedom will be same, n minus 2, because in this case there are two variables, x and y. So n minus 2, whatever observations are there in the one series, minus 2. So that will be degree of freedom. Level of significance you may also take into your account as 0.01 or 0.05 or 0.10. So it's upon you. But utilizing this formula, you will be able to say something about the rejection or exception of the null hypothesis like this. So let's say you are going to accept the null hypothesis. You are going to accept the null hypothesis. So in econometrics, you will find out this value. What is this? Standard error of estimate. What we call this? Standard error of estimate. So this is the estimate. This is the estimate, and this is the standard error of estimate. So you can find out the standard error of estimate from the series that you will have for beta hat. So we also call this standard error of estimate. We also may find it out as you have already seen in the last chapter. So standard error of estimate could be find out using this formula, ESS, error sum of square divided by n minus 2. So if you have the ANOVA table, in that table you will have some value for ESS, error sum of square, or within sum of square. Okay, so if you have that value and divide that value with n minus 2, okay, so you can find out the value for standard error of estimate. So this is the standard error of estimate. So you can find out this value from the ANOVA table, and remember that this is the value when you will take into your account single independent variable. Okay, so for different estimates, let's say there is an equation like this, y is equal to multiple regression analysis. In that you will see that plus beta x plus, let's say, gamma. This is beta x1 gamma x2, okay, plus mu I, okay. So there, see, there is no hat on this, on any variable, okay. So definitely there will be, in this case, let's say you are interested in finding out the you want to confirm that whether the slope parameter beta, there is some value for this or not. So beta hat minus beta will be there. So beta hat for the sample, and here you will write down beta hat. Okay. And if you are interested in finding out whether there is some relationship between x2 and y, so for that you have to see that whether gamma is equal to 0 or not. If it is equal to 0, then 0 multiplied by x2, the result will be 0. It means that the whole series will become 0 and there will be no impact of x2 on y. Okay. So therefore you have to confirm that this gamma is not equal to 0. If it is not equal to 0, it means that there is some relationship between x2 and y. So similarly, in this case, if beta is equal to 0, you are going to accept the null hypothesis. It means that beta is equal to 0. So there will be no impact of x1 on y, x1 on y. Why? Because if beta is 0, 0 multiplied by something, the answer is 0. So there will be 0 impact on y if you are going to take x1 into your account. Fine. So you have to confirm this. You have to set this null hypothesis. So in this case, gamma. For gamma, you will see that the formula for T will be like this: gamma hat minus gamma. So gamma you are going to set as 0, and gamma hat you will have some value for that. And here you will write down the standard error of estimate. So here in this case, S gamma hat will be there. Understand?
Yes,
Yes,
sir.
sir.
Okay. So you will
Yes.
see that some calculated value you will obtain utilizing these formulae. Okay. And the tabulated value or the critical values you will obtain using the T table. Degree of freedom could be found out n minus 2. If there are two series n minus 2, so you will take, let's say there are 10 observations in the, X series. So n will become 10. Okay. And if there are two series X and Y, you will subtract 2 from that to find out the degree of freedom. Fine. And let's say there are let's say 5 variables, 5 independent variables are there, and the 6th is the dependent variable. So degree of freedom in that case will become n minus 6. Understand? So in this way you will find out the degree of freedom that you will use in T statistic table. Fine. So in this way you will find out the calculated value and the tabulated value, and then you will be able to prove or disprove the null and the null hypothesis. So let's say if you are going to reject the null hypothesis, you will be definitely going to accept the alternate hypothesis, and exception of this will mean that beta hat is not equal to 0. Not equal to 0 means there is some relationship between the independent and the dependent variable. And if you are going to accept the null hypothesis, this will mean that there is no relationship between X and Y, the independent and the dependent variable. There is no impact of X on Y if you are going to accept the null hypothesis. Right? Clear or not?
Yes, sir.
So I think
The
this
degree
is
of
sufficient.
freedom का independent or dependent variable है इसकी थोड़ी information.
Sorry?
सर डिग्री ऑफ फ्रीडम में इंडिपेंडेंट और डिपेंडेंट वेरिएबल का मैं कैसे पता करूं?
No. You simply have to count the values. Okay, you simply have to count the values, that how many values are there in the series. Let's say this is the series. Blood alcohol content. Let's say this is BAC, blood alcohol content, and beers. These are the bottles that are being consumed. So somebody is consuming 6 bottles. Okay, and the blood alcohol content that is there in the body of the person who is utilizing 6 bottles is this. So more bottles. Okay, so this is upon the consumer, that how many bottles he is going to consume. He is independent. Okay, but resultantly what will occur to his blood, this depends upon the consumption of the beer's bottles. Somebody is consuming 6 bottles. It is his discretionary power. He may use 10, he may use 11, he may use 100. Okay, so independent variable. This will be independent variable. This will be dependent variable. Why? Because this will be a result of this independent variable. Fine. So what you will do for the degree of freedom, you will simply count these values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I don't know how many values are. Let's say 20 values are there. So you can count it. Let's say 20 values are there over here in this series. Okay. So then you will subtract 2 from this 20 to have the degree of freedom. 18 will be degree of freedom. And let's say there are some other series. Let's say X. This is X. This series is X1. The next series is X2. Let's say beers. Okay, beers bottles. Okay. There may be some other reason for the blood content, blood alcohol content in that person. There may be several reasons for that. One is the consumption of alcohol, or there may be some other disease. So if you have data for other disease, that will be X2. Okay. There may be some other variables. Okay. So if let's say there is only one variable here, this is the beers, and another variable is let's say X2. Okay. So then how many total variables will be there? One independent and two independent and one dependent. So 3 variables will be there. So 20 values, 20 minus 3 will be the degree of freedom. In this way, you will find out degree of freedom. Now, another very important thing that I want to explain, and then I shall conclude, is that you have seen, I have written over here, y is equal to alpha hat plus beta hat x plus mu hat. You can write down subscripts over here: yi, xi, mu I. So that is for the values that you will obtain by substituting different values. So let's say if you are going to write down it as yi, xi, mu I. So different values will be there. Let's say if x is xi, let's say 10th value of x, I from 1 to so on up to n. I from 1 to up to so on up to, let's say, n. Okay, these are the values for I. So in data series, the first value x1 will be the first value in the data series. The first value x1, what will be the x1 value? This is x1, this is x2, let's say x1, x2, x3, x4, and against these values, whatever you will find out utilizing this equation, I mean, you will substitute the value for alpha and the value for beta. Okay, and here you will substitute the value 6, this 6. So in fact, the actual value of y is this, but when you will substitute this value in this equation, definitely you will have some other value, and that value will be like this, y hat. So in fact, this has occurred. Okay, but when you will substitute this value in the equation, okay, the estimated equation, this is the equation that you have estimated. Okay, the estimated, because you have in this case, you know what is the value for alpha, what is the value for beta. So when you will substitute this 6 here, this will be the answer. When you substitute this 7 over here, this will be the answer. So these are the predicted values. These are the predicted or forecasted values, and these are the actual values, y and y. These y values are the actual values. This has occurred actually. And you have made this person consumed 7 bottles, and you checked this person and you confirmed that there is 0.09 blood alcohol content in his blood. Okay, but when you will substitute this value in the predicted equation, you can see that this is 0.1. So this 0.1 is just near to this. If you round off this, you will have 0.1. This is equal to 0.1. So definitely this difference will be there. You cannot remove this difference. You cannot remove this difference. What best can you do? You can minimize this difference, and this is the best strategy that we do. Okay, so this is what we call the ordinary least square method. We basically want to reduce the difference between these two. So as you have seen that the difference between these two, the value was 24 in one case, and in some other case it was 44, in some other case it was 32, 132. So you preferred 24. Why 24? Because that was the minimum value. you have seen over here in today's lecture. So basically, we are interested in minimizing this distance. Okay. So now you can see another important concept. If you write down the population equation like this is y hat plus mu I. If you are going to write down the population regression function like this, because in this you can see these two terms are there, alpha hat plus beta hat x. So if you are interested in finding out mu I, what will you do? You write down y minus y hat. What this means? This is the error term. This is the error term. This is that difference you saw in the graph that were there. This difference. This was mu I, y hat, y hat. So you can see over here mu I. So if you are considering the population into your account, it will be mu I. If you are going to consider a sample data, so mu I hat will be there. Or you can also call it EI. In some books, it is EI. So EI is equal to y minus y hat. So this y minus y hat, this you can find out y hat's value using the values of x in this equation, and actual values will be there. And finally, you will have EI. EI will be the difference between these two, y minus y hat. Okay, and you are interested in minimizing that difference. And definitely, when you will use alpha and beta, and you are going to obtain these values, the values of alpha and beta using the OLS method, ordinary least square method. So these are the values. These are the best values that will produce you, that will give you the value, the prediction, the y hat value, that will be the best estimate for the population variable y. So these parameters, these estimators will give you the best result, the best prediction. Okay, so you will see several things in econometrics. Don't worry, inshallah, that everything will be all right. So almost we have covered basic things that are important when you will see the econometrics. So another thing that I've just recalled is that regarding what is coefficient of determination, that is R square. So you will have some value for correlation coefficient, and when you will take square of this, and normally we take it as R square. This is another important thing that you will see in the econometrics. R square. What is R square? R square is basically the square of R, whatever value you will find out for R, and you know how you will find out R using these the formula that I have written over there. X minus X bar to Y minus Y bar divided by N minus 1 Sx Sy. Using this formula, you will have some value for R, and when you will take square of this R, you will have R square. You will have R square. What we mean by this R square? We call this coefficient of determination. And what we mean by this coefficient of determination is that if you see this equation, here you can say that let's say this is one part, this is another part. Okay, let's say R square, the value for R square is equal to, let's say the value for R square is equal to, suppose it is 0.65, let's say. So this 0.65 will mean that 65% of the change, 65% of the change in Y, the dependent variable, is because of the included independent variable. Understand? 65% change in the dependent variable is because of this R square will help you in finding out that 65% of the change in this dependent variable is because of the included independent variable. And there are so many and there are so many other variables that we have not included in the regression equation. So the remaining, so please switch off your mic so that there is no noise in the. Please switch off your mic if somebody has opened it. Okay, so please switch it off. I'm just concluding. Please wait. 65% variation in the dependent variable is because of the included independent variables, and definitely 100% change will be there. So 100, so you can write it down as point. Let me write down point 1.0 minus 0.65. What is the answer? This is equal to 0.35. 0.35. Understand? The answer is 0.35. It means that 35% of the variation in Y is because of the leftover variables that we have not included in the analysis. Okay. 35% variation is because of the variables that are not there in the analysis. So if you are going to take into your account so many variables, even then some variables will be left over. Okay. So what best strategy is will be there? We are basically interested in reducing this value by including some other variable. This value will be reduced. Okay. So if you are taking into account multiple regression analysis, you will include, let's say you are going to include 10 variables in the regression analysis. Okay, so this value will be reduced. Okay, and this value will be increased. Okay. So basically, we are interested in reducing this value, and this value will be reduced by including more variables. So there should be some theoretical sense when you are going to introduce the other variables. So more variables are there in the analysis, the more good will be the prediction, okay, regarding the future, and that definitely depends upon that what analysis you are performing. So this is all for today, and I am confident that you have learned a lot. And these are very basic things that normally students don't know even after completing the econometrics course. So I think I have tried my best to develop your interest in learning econometrics. So hope for the best, and if you have any question, you may ask right now. Otherwise, I'm going to conclude lecture.
सर सर इस पे
Yes.
अगर एक सवाल हो जाए सर, मतलब मैथमेटिकली सारे स्टेप कवर हो जाए इसमें.
So because today is our last class, okay, so that is not possible for me to complete one big question for you at this moment. But you can see from your book, and it is quite possible that there is a question from your book in the examination. It is quite possible. So you can see my previous lecture, and you can solve this example, and this will help you a lot in understanding the concept. This is there in your book, example number 12, chapter 13. So see this. I have solved this example over here. You can see this in Excel. I have solved. Okay. So I have found this R, and further I have solved this for the alpha and beta values for the estimators, and then I have found y hat. Okay. So you can see over here, but these all details will be there in the next course of econometrics. But simply whatever I have explained, you can see these things in this chapter, and you may expect a question from this chapter that definitely will be up to the level that I have explained. Okay. So
ओके
you
सर,
can
ये
see.
स्लाइड शेयर करें सर.
Okay. Okay. So I shall explain. So a few things have remained. You can see over here what is R square. We can also find out coefficient of determination using that formula, where we find R and then we take square of R. And otherwise, if you have a ANOVA table, the values are there in the ANOVA table, then regression sum of square divided by the total sum of square. You can see this from here. These are the formulae. These are the formulae basically that we will use in the next course. They are not you can say relevant in this course, but you are familiar with this ANOVA table. And RSS means regression sum of square, okay, and residual sum of square is ESS, and this is total TSS. So ESS, RSS, and TSS. So these values may be utilized over here. If you are interested in finding out coefficient of determination, then SSR divided by TSS or RSS divided by TSS, or otherwise you may also use this formula 1 minus SSE over uh, total SS TSS. So you can write it down as ESS or SSE or SST or TSS. It's upon you. You can write it down anyway. So standard error of estimate you can find out utilizing this formula. This is SSE or ESS, okay, divided by this. So in this way you can find out standard error of estimate that you will use in the in the test statistic, that in where you will find out T calculated to confirm that whether the same impact of the independent variable is there in case of population or not. Okay. Or you can simply take residual mean square. So MSE, this is basically MSE. So simply take MSE, square root of MSE. I mean this value. Take square root of this value, and you will have the standard error of estimate. So I will share this slide with you, but remember that these all things are there in your book, and you are supposed to prepare these things also for the examination. So any other question?
सर ये अगर पेपर में आए तो ये ANOVA टेबल तक आएगा?
So ANOVA table you may be required to prepare an ANOVA table. If values are given, so that is not difficult. You can prepare these values. You can you may be able to find out the degrees of freedom. You should be able to find out the sum of square if some relevant things are there. So definitely some values will be there in the question, let's say, but I think don't go in that detail. Simply see that ANOVA table in case where we have discussed one-way analysis of variance and two-way analysis of variance. For these things, don't go in more detail, because in detail you will learn these things in the econometrics. Few basic things may be asked in the question in the examination. So up to the level, up to the point I have covered this chapter, you may prepare for the examination. Any other question? No question? Okay.
No, sir.
Thank you very much.
Thank you, sir.
Wish you very good luck for the examination.
Thank you, sir.
And
Thank you, sir. Hello, sir.
no, don't leave the class, because I will write you present later on after stopping the recording.
Yes, sir.
Thank you very much. Allah Hafiz.